What you are looking at are two breadboards that were connected one at a time to the modified Astrocade motherboard. The left board runs only in the low-res mode. The right board is the project board that will run both in the low and high-res modes and will be used to run experiments. At this time, this breadboard is wired only to run in low res. Both of these breadboards have already been tested and run perfect in low res. This is a closer view of the low res mode only breadboard. This scheme will eventually be wire wrapped on a hobby board. The intent of this board is to be used as a diagnostic tool to isolate a future failure that might occur on the modified motherboard or the low high-res screen RAM board number 1. Should a failure occur, connecting this working backup low-res only board will help determine if the failure is in the motherboard or the screen RAM board 1. A 74LS123 and 3 gates used as inverters in the 74LS00 chip provide an adjustable active low RAS line. The 3 chips labeled U14, U22, and U21 are wired similar to the same 3 chips on the motherboard. There is an extra flip-flop in U21 to generate the active low CAS line, which is used as the static RAM chip select. The 74LS373 latches the row address to the RAM chip. The single RAM chip replaces 8 dynamic RAM chips. None of the 6 1K ohm pull-up resistors are required for the RAM address lines A0 to A5. What you're looking at now is a setup to test the low-res only breadboard. Check out this setup. In the center is the modified motherboard. It has no RF shielding. There is the usual piece of metal glued to the custom data chip. There is a black finned 40-pin heatsink on top of the address chip with silicone heatsink compound in between. There is a 6-inch fan which runs at low speed, pointing at the custom chips and power supplies to keep heated components cool. There is a composite video and audio drivers breadboard sitting on top of the RF modulator. To the left of the motherboard is the connected low-res only breadboard. On the other side of this breadboard is the plus 5-volt power supply for this low-res only breadboard. On the other side of the motherboard is my power transformer substitution board, which is connected to the motherboard. I am not using a standard black power transformer which plugs into a wall outlet. Behind the motherboard is my BalcheckHR breadboard, which is connected to the motherboard 50-pin expansion. Behind this setup is my 20-inch Toshiba CRT TV. You can't see the TV at this time. I have 3 120-volt AC power cords connected to a power strip. The motherboard power switch is slid to the on position, so the power strip will turn on the 120-volt AC power to the boards simultaneously. The 6-inch fan is connected to the wall outlet and is already on. It's time to run some tests. I'm going to turn on the power strip now. I'm going to run 3 short programs. First, I'm going to run Checkmate for 1 round. Now I'm going to introduce to you a diagnostic program called Balcheck. This program executes a series of tests on the motherboard. If a test discovers an error, that error will be reported on a dual 7-segment display. Since the motherboard and low-res only breadboard are running perfect, you will see on the TV screen the Balcheck program testing the screen RAM and exercising the sound ports. You will see Balcheck do this 4 times. I have to set up the BalcheckHR board first. Here's Balcheck. One, 2, 3, 4. I will run Balcheck once more. Now watch the dual display on the bottom right of your screen. Here's Balcheck again. The dual display will initialize to --, then count up, and will finally display E1, indicating all 4 run passes executed with no errors. I will run Balcheck once again. Watch the display again. Initializes the --, starts counting up, and Balcheck runs through 4 passes testing screen RAM. 4th pass now. E1 is displayed. When I connect the project breadboard to this motherboard in a little while, I will show you how Balcheck reports an error on the dual display. Now I will run my 3rd and final program. This program is also a diagnostic tool and is part of my 32 KB BalcheckHR board package. This program is called the Z80 Check program and is a very useful tool when a motherboard powers on with the black screen. Again, I have to set up the BalcheckHR board for this program. Here's the Z80 Check program. There are simple graphics similar to my set screen diagnostic program, which are displayed on the TV screen. Depending on the motherboard failure creating a black screen power on, Z80 Check may display TV graphics when the power on menu fails to display TV graphics. Now look at the Balcheck dual display. It's counting up in hexadecimal. This indicates the Z80 is executing. You can continue watching to see if the Z80 is executing perfect. If the display is not counting up, there is a failure somewhere related to the operation of the Z80. This Z80 Check program really helps isolating a failure when all 3 motherboard power supplies are functioning correctly and there is a black screen power on. It's time now to look at the high-res project breadboard. Here's a close-up view of the project high-res breadboard. The generation of the screen RAM control lines is similar to the low-res only board that you have just seen, and expanded to select 4 high-res screen RAM banks. Some series resistors and a data bus 74LS245 chip were also added. This board is now only wired for low-res operation. The project high-res breadboard is now connected to the test setup. I'm turning on the power strip right now. I'm running checkmate for 1 round. Now I'm going to run Balcheck. One, 2, 3, 4. Balcheck is reporting E1. No errors in the 4 passes. Now I'm going to simulate a screen RAM data line error by disconnecting the video data line 5 on the load side of the 74LS245 chip. Here's the data bus line here. Data line 0, 1, 2, 3, 4, 5. Running Balcheck. Balcheck has detected an error right away. Look at the dual display. It's displaying a repetitive error sequence, an error report of, wait for it, 04 capital I 20 HE LP. The error report, as I mentioned, is 04 capital I 20 help. 04 is the error code, which is indicating a RAM error. The capital I indicates the info byte follows. And without going into detail, the info byte is indicating there is a video data line number 5 error. Now I'm going to reconnect that wire. Running Balcheck again. Okay, I reconnected that wire. Balcheck is reporting again E1. No errors on the 4 passes. You have just seen an intro to Balcheck, sometimes called Balcheck. This is a pretty cool diagnostic tool. Here's another diagnostic tool called the Remote ROM program. I have to set up the HR board for this. Here's the remote ROM program. What just happened? The motherboard ROM chip right here has just been disabled, that is turned off. Now the system BIOS is operating by the EEPROM on the BalcheckHR breadboard. There's an 8KB low-res BIOS on this EEPROM that's operating right now. The remote BIOS has been altered slightly, changing the menu colors and bottom line of text. Here's Checkmate running. This remote ROM diagnostic program is useful when you have a motherboard ROM chip that you suspect is acting up. You can run the remote ROM program to confirm your suspicion without replacing the motherboard ROM chip. Well, that's the end of my progress report number 2.